Hey, this is Mr. Warden. This is a video key for Do Now 23.2, week 23, number 2, or day 2, I should say. So here we go. I am thinking of two numbers. They add up to 26,972. And the bigger number is 937 bigger than the smaller one. What are the unknowns here? How could we represent them? Well, if they're unknowns, then the unknowns are simply the two numbers. And we could represent them by x and y. And I'm going to make a choice to say x is the bigger number, because that will allow me to arrange my equations nicely with this. So if we came up with two numbers being the unknowns, you got it. We could represent them as x and y. So let's see if we can come up with a couple of equations that we could create for this. So if these two unknowns add up to 26,973, we could say x plus y equals 26,973. And if we say that one of the numbers is 937 bigger than the smaller one, well, that's a difference. So we could say x minus y equals 937. You might also have said x equals 900, or y plus 937 or something like that as well. That would be completely legit too. But I'm going to work with these two here that I've come up with. This one would totally work, but these will work a little better for what I have in mind, just simpler. So here we go. If we came up with these two, those will represent it pretty well. So let's open up Desmos. I'm going to copy pasta all of this real quick. So I'm going to open up Desmos. And in Desmos, I'll plop that there. And I'm going to get rid of that. I'll plop that there and get rid of my and. Okay, now I have two equations. And what I'm asking you to do is graph them and then zoom out to find their intersection. So I've put them in here, and you're like, but Mr. Ward, where's the graph? Well, to find the graph, you'll have to zoom out because I'm dealing with some pretty big numbers here. So let's go zoom, 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 a whole bunch of zooming. And when we get there, we have an intersection point right here. 13,955 and 13,018. And that's the point that we get there. So I'm going to write that down. 13,955. And what was the other part of it? 13,018. So what do these numbers represent? Well, it turns out that these numbers represent x and y because they are x and y. This is the x and y that will work for both of these equations because it happens to be an x and y where both of these equations intersect. This is a system of equations. We're considering these two equations together, which makes them a system. And this here, this point, is a solution to this system because it is a point that makes both equations true. And we can test that out. I can say, okay, 13,955 plus 13,018. And look at that, I get 26,973. And then I could say 13,000, I'm just going to replace x and y with this 13,955 minus 13,018. And look at that, I get 937. So when I replace x and y with these in either equation, with this x value and this y value in either equation, I make the equation true. So that makes them a solution for this system of equations. Okay, cool. So we solved it by graphing. But let's see. So let's write that down. So we get the point 13,000 955, comma, 13,018, and those represent those are the two numbers I had in mind, because they make both relationships, the equations that is, true. Okay, cool. So now the next question asks us, what would happen if we stacked the two equations on top of each other and added them vertically? So you might remember back in the day in equations when I had you subtracting two equations from each other. What I can do is I can subtract every part of this equation, or I can add every part of this equation on the left side of the equal sign and also on the right side. So let's see what happens when I do that. So if I have x plus x, that's 2x. And then if I have y plus negative y, that's plus 0y, which is nothing, by the way. I'm going to get rid of it in a second. And if I add 26,973, well, let's work that out. 7 plus 3, that's a 10. So I'll carry the 1. Let's go ahead and do that. Okay, so that's a 0. Carry the 1. 7 plus 3 is 10 plus 1, that's 11. Carry the 1. 9 plus 9 is 18. Add the 1, that's 19. Carry the 1. I should probably make that 9 a real 9. And then 6 plus 1 is 7. And then I've got a 2. Okay, so I end up with 27,910. And that is what I end up with. Now, it's kind of cool because now I can just make this 0 go away. And I could actually divide both sides by 2. So x would equal 27,900. Let me actually write that. 910 divided by 2. Well, let's see what that is. Go to Desmos, let it do the thing. 27,910 divided by 2. Oh, look at that. It's 13,955, the same number we just got. 13,000, so x is going to equal 13,955. Okay. I'm going to just drop that comment. It is customary to have it, but it gets in the way in certain circumstances. So if I had the number longer, I would probably put in the commas. Now let's consider, so this time we added the equations. The y value, the y variable disappeared. It was eliminated. And then we had one variable and we could solve for it. What happens if we subtract the equations? I subtract this equation from this equation. So if I do x minus x, I'm going to end up with 0x. And then if I do y minus negative y, I'll end up with 2y, because subtracting a negative is like adding a positive. And then if I do subtract 937 from 26,973, well, I'm going to have to do the calculations. I'm going to have to borrow here, so that'll be a 6. That'll be a 13. So 13 minus 7 is going to be 6. Okay, now 6 minus 3 will be 3. 9 minus 9 is 0. 6 minus 0 is 6. And 2 minus 0 is 2. So I get 26,036. Okay, so that is 26,036. And now I can get rid of the 0x, and I just end up with 2y equals 26,036. And I can divide both sides by 2. So y will equal 26,036 divided by 2. And that's going to equal, well, let's see, 36 is easy to split in half, and 26 is easy to split in half. The 26 becomes a 13. 0 18. 13,018. Let's take a look here. Isn't that is the y value? And look at that. Y equals 13,018. So I have just subtracted the equations, and because these two variables had the same coefficient of 1, they disappeared. They were eliminated, and it left me with a 2y, and I could actually work out what y was because I only had one variable to deal with. And in 1D, I was able to add the equations, and because these two had opposite coefficients, positive 1 and negative 1, they went bye-bye. They were eliminated as I added the two equations together. And I had just one variable then, and I could solve for what that variable is. All right, I hope that was helpful, and I will stop making the video.